Welcome to today's math lesson on representing linear non-proportional situations with tables and equations. Our do now is this equation y is equal to half times x, so it's a proportional relationship, and we have to fill out the table for it. So we have to fill out the x values, the process, so the equation multiplying by the x values, and then the subsequent y values. So for this problem, I'm just going to choose different x values, and I have 0, 1, 2, 3, 4, and then 5. And so for my process, I'm going to be multiplying half by each of these x values. So half times 0 is 0. So that means that one of the coordinates on the graph is 0, 0. Then when x is 1, I'm multiplying half times 1. And that's half. Then I'm multiplying half times 2. And that's 1 whole. Then I'm multiplying half times 3, and that's 1.5. And then I'm multiplying half times 4, and that's 2. And lastly, I'm multiplying half times 5, and that's going to be 2.5. So it's actually going to be 5 over 2, but once we convert this improper fraction to a mixed number, it will be equivalent to 2.5. Today's TEK is 8.5b. The lesson target: scholars will be able to represent linear non-proportional situations with tables and equations in the form of y equals mx plus b. And our deal well is given 4 problems. Scholars will be able to represent those linear non-proportional situations with 100% accuracy. Some academic vocabulary words to go over are ordered pair, proportional relationship, rate of change, x-coordinate, y-coordinate, linear equation, slope-intercept form of an equation, and the y-intercept. So the only new vocab words for today's lesson is the slope-intercept form of an equation, and the slope-intercept form is always y is equal to mx plus b. So if we compare that to our proportional relationship equation, which is y equals k times x, you'll see that there's a new variable or a new part to the equation, and that is this y-intercept. So, which is represented by b in the slope-intercept equation. So if we have a graph, and let's say that this is our proportional or non-proportional linear line, this point right here is going to be our y-intercept. It's where the line intercepts or cuts across the y-axis. And for our non-proportional relationships, our constant of proportionality, our unit rate, our rate of change, which was represented by k, is now going to be represented by the letter m, but it's essentially still the same thing. We also want to review some different vocab words such as the word quotient, product, sum, and difference. So quotient is the result of division of two numbers. So product is the result of multiplying two numbers. Sum is the result of adding two numbers, and difference is the result of subtracting two numbers. So our introduction question, we have, let's examine the linear relationship y is equal to 2x plus 3. We can create a table to represent the relationship. So we already have our x values filled in, so 0, 1, 2, 3. We have our process filled in, which is the equation 2x plus 3. And now we have to fill that part out as well as find out what the y values are. So when x is 0, I'm going to plug in 0 into the equation, so 2 times 0 plus 3, which is going to be 3. When x is 1, I'm going to plug in 1 into the equation, so 2 times 1 plus 3, which is 5. When x is 2, I'm going to plug in 2 into the equation, so 2 times 2 plus 3, which is 7. And when x is 3, I'm going to plug in 3 into the equation, so it's going to be 2 times 3 plus 3, which is 9. So now I'm going to take the numbers, the x and y values from this 3 process chart, and put it into this horizontal table. So when x is 0, y was 3. When x was 1, y was 5. When x is 2, y was 7. When x was 3, y was 9. And just to check to make sure that this is a non-proportional relationship, so if we're using our constant proportionality equation, which is k is equal to y over x, we're taking different pairs and setting them equal to each other, right? So we have 1 comma 5 would become 5 over 1 because 5 was our y value, 1 was our x value. And then we have 2 comma 7, which becomes 7 over 2. And lastly, we have 3 comma 9, which in the constant of proportionality formula would be 9 over 3. So these are all not equal to each other or non-equivalent. And so k is not constant. Therefore, this is not a proportional relationship. This first I do problem reads the equation y is equal to 3x plus 2 gives the total charge y for bowling x games. So x is the number of games and y is the price. At Baxter Bowling Lanes based on the prices shown. Make a table of values for this situation. So we have our 3 process column chart. So we have x values filled in. We have 0, 1, 2, 3. And then we have our equation written for us, 3x plus 2. So now we just have to fill out the x values and then solve for y. So when x is 0, I'm plugging that into the equation. So it's 3 times 0 plus 2. 3 times 0 plus 2 is 2. When x is 1, I'm plugging in the 1. So we have 3 times 1 plus 2, which is 5. When x is 2, I'm plugging in the 2 into the equation. So we have 3 times 2 plus 2, which is 8. And when x is 3, I'm plugging in 3 into the equation. So we have 3 times 3 plus 2, which is 11. So from here, I'm going to plug in the y values into our horizontal table. So we have when x is 0, y was 2. When x was 1, y was 5. When x was 2, y was 8. And when x was 3, y was 11. This next I do problem reads, Mr. Fixit charges $30 for a service call and $50 per hour for labor. Which table is the correct representation of this scenario? So what we're going to do first is write an equation in that slope-intercept form. So per hour is a hint to tell you that you're multiplying 50 by a variable. And so that usually tells you what your unit rate is if you have the word per. So in this case, our equation is going to be y is equal to 50x, and x is going to represent the number of hours of labor, and then plus the $30 for the service call. And from here, I'm going to plug in 0, 3, 6, 9, 12 to figure out what the y value should be. So 50 times 0 is 0, plus 30 is 30. So the first y value should be 30, so it's not going to be A. Then we have 50 times 3 is 150, plus 30 is 180. Okay, so both of B and C have that value. Then when x is 6, 50 times 6 is 300. 300 plus 30 is 330. Both of them have 330. So the only difference in B and C is the y value for when x is 9. So 50 times 9 is 450. 450 plus 30 is 470. It's 480. I apologize. So 480, our correct answer is going to be C. There is a similar we do problem, and then some you do problems. If you want the solutions to these we do's and you do's, I'm going to include the link to the solutions PowerPoint in the description. And now it's time for your DOL. So given 4 problems, scholars will represent linear non-proportional situations with tables and equations with 100% accuracy, and it's in a Google form. Thank you so much for following along and paying attention in today's lesson, and see you in the next math video.